Hi everyone, hope all are fine. So today I am going to do the electrolytic extraction of metal by electrolytic method. So first I'll write down the heading metals and non-metals. Metal and non-metal. Okay, so basic method we have done all the methods in that crushing. First is crushing and grinding of ore, concentration of ore, extraction of metal from the concentrated ore, and last we are refining of metal. In extraction of metal from concentrated ore, we have done all the reduction process by what heating, by using reducing agent, and now I am going to do it by electrolytic process for the reduction of oxides, which are the highly reactive metals. For the medium reactive metals, and for medium reactive metals we used certain reducing agent like a carbon monoxide, coke, aluminium. And for those metals who are in low in reactivity series, for them by heating only we have just converted them into metal oxides and we have reduced them. So now I am going to discuss about the electrolytic reduction. So reduction of oxides, of high reactive metals. Okay, so we know Na, sodium oxide, Na2O, K2O. So these are called very high reactive metals, and we have to reduce these metals. For that reason, which method we are using here, electrolyting. What is meant by electrolysis? By passing electric current, we are just breaking down that metal oxides and we are separating the metal from that. That is only the reduction process. So reduction of highly reactive metals we are doing by electrolytic reduction. So I will write down the electrolytic reduction means what? Electrolytic reduction. So in this one we are using electrodes and one we are using electrolytic solution. So electrolytic solution will be there in the form of molten state. For example, we have converted bauxite, I write down here, bauxite by crushing and grinding, these two process, crushing, grinding. Later by Bayer's method, we have just converted them into by Bayer's process or Bayer's method. We got a Al2O3. This is called alumina, but this is in the form of solid alumina. Okay, so bauxite, already we discussed about the bauxite. This is the bauxite we have extracted from the earth crust. Later we done the crushing and grinding, this common process or basic process. Later we did the Bayer's process. By that Bayer process we got a alumina, which is in the pure form, but it is a solid form. But for this electrolytic reduction purpose, we want in the molten state. For that purpose, we are adding CaF2, that is fluorspar, and this one cryolite, Na2Al(F6), Na3 it is, Na3Al(F6). This is called cryolite, and CaF2, that is a fluorspar that we are adding in the Al2O3. Why we are adding in the Al2O3? Because this is in the solid form and we are converting into the liquid form. For that reason, Al2O3 it has a high melting point and is a poor conductor of electricity. By adding CaF2, we can just reduce its melting point, and by adding Na3Al(F6), we are making it Na3, that is cryolite, we are adding to reduce its melting point, and fluorspar we are using for the conduction of electricity. For that purpose, we are adding both the agents. So now we are adding, after adding this agent, it will become a liquid form, molten form of Al2O3. So now we have taken Al2O3. This is a molten form. So now here two electrodes are there. One is a cathode and one is an anode. So anode, it is a here at the anode reduction process will be there. So which is the pure metal, it will be get deposited on the cathode, and whichever the impurities are there, that are deposited on the anode. So by like this process we are just doing the electrolytic reduction. We are getting the metal reduced here, metal oxide, which are we are getting in the form of reduction as a pure metal in case of electrolytic reduction. So next again, which process we are going to do? Refining of metals. So refining of metals. In case of refining of metals, we are using three methods. One is liquefaction, second one is distillation, third one is electrolytic refining. Electrolytic refining. Okay, so these are the three methods for refining metal. So this is the last method of metallurgy process. So what is meant by liquefaction? The metals, those metals which have a low melting point, for that metals we are using this liquefaction process for the refining of that metal. For example, we can take an example of lead or a tin. So how we are by this process we are refining this metal. We can take here a sloping core, sloping here, and this is a jar. So we are heating these metals. So the metal like a lead or tin, they are getting melted very easily because they have a low melting points, and we are collecting in this jar. So like this we are just separating this metal, refining this metal in this liquefaction process. So what is the main basic principle of the liquefaction is difference in melting properties of impurity and metal. So which for example, metal have a low melting point, so it will get melt easily, and we are collecting it, we are separating it from impurity. So whichever the impurities are there, they are setting on this this sloping earth only, and whichever the metals are immediately getting melting, they are collected in the jar. So in this process, so this is the process of having a low melting points of that metals. Okay, so I'll just write down the principle of liquefaction process. Normally, which kind of metals we are using in the liquefaction process? The metals which have a low melting points, metal, we are just using it. And the difference in the principle of this liquefaction process is difference in melting properties of metal and impurity. Okay, so this is about the liquefaction. Next we'll discuss about the distillation process. So for the distillation process, for example, any metals which are in the liquid form, we are heating them, then they are converting in the vapor form. Again that vapor form, by cooling it, again we can make in the liquid form. So this is about distillation. So I am going to discuss the example of this distillation process is metals. Example is mercury, cadmium, or zinc. So these are the metals we can do the distillation process for these metals. So what is the distillation method? So I'll write down here. For example, we can take an example, liquid is there. So liquid we are heating it, so it will convert in the vapor form. And again vapor we are cooling it, then it will become a liquid. So the process I will discuss here. This is a bottle. Here the metals we can keep, we are heating it. So those metals which have low boiling points, they are getting evaporated in the form of vapor, and that vapor we are collecting in this jar. So like this we are, and whichever the impurities are there, they are not getting volatile, or they are not getting in the form of vapor, so they will be settled down in the at the down only. So this is the process of distillation. So I'll write down the principle of distillation here. Distillation process is mainly done for the metals which have a low boiling points. have a low boiling points. Difference in the boiling points of impurities and metal. Difference in the boiling points of metal and impurity. Okay, so again I can explain this. Distillation means what? Distillation means the metals which have a low boiling point, for them we are using distillation process. We are heating, for example, metal in the form of liquid is there, so we are just heating it, so it will convert into the vapor, and again that vapor we are converting back into the liquid form by cooling it. So this is about the distillation. So how we are doing it? We are heating any, for example, any metals are there that we have to refine it. We are heating it. So those have low boiling point, they are getting in the form of vapor. So that vapor we are collecting in the separate jar, and whichever the impurities are there, they will be there only at the down of the, or at the bottom of that jar. So like this we are separating metal, or we are refining that metal by distillation process. And next, very important for the board exam point of view, that is the electrolytic refining. Electrolytic refining. Okay, how we are doing this process, electrolytic refining? Already we discussed what is meant by electrolysis. We are breaking that strong, highly reactive metals. We are breaking it by what? Passing a current. That is only called electrolysis. And refining means we are extracting the, we are removing the impurities from that metal by using a electrolysis process or electrolytic process. So I'll write down the, first I'll write down, explain the process, and later I can write down the definition for that. Okay, so this is about the one, we can just take a one vessel here, and two electrodes we are taking here. One is anode or one is cathode, and we are using battery, key, everything. We are passing current, and later this is a battery. Okay, so it is a positive charge, it is a negative charge here. So it means all the, it, we call it as a cathode. Negative charge is having cathode. Here positive charges, we call it as the anode. And we are taking a solution of NaCl now, because sodium, it is a highly reactive metals. So we can take an example of NaCl. So by passing current, this NaCl in the molten form, it is in the molten form. So now this NaCl, it will break down in the form of Na plus, Cl minus, Na plus, Cl minus, like this it will break down. Later we know already opposite charges, they get attract toward each other. So here it is a negative charges, cathode has a negative charges. So all the Na plus, they are getting attracted towards the cathode, or they gain an electron. So Na plus, it will gain an electron, it means it forms Na. Now it becomes a solid. It was in the liquid state, but once Na plus it get attaches with the cathode, it gains electron, because all the negative charges are there. So it gains electron, and it will become a sodium in the form of solid. So this is about what? Reduction process. So this is the reduction. Reduction means gain of electrons. Gain of electrons. Okay, so here we can write down, so this is the reduction process already done. So in case of anode, so all the Cl minus, so this Cl minus, they are getting attracted towards the positive charges. So now Cl minus, it will lose its electron, and it will form a Cl only, chlorine. So again Cl minus, it will lose its electron and form a Cl, like this Cl, it will become a Cl2, and they are forming a gas here on the anode, and it will be evaporated as a gas, this Cl2 gas. So like this process, whatever the metal we want, that are depositing on the cathode, and whichever the impurities are there, that are getting deposited on the anode. So by this process, electrolytic refining process, we are separating sodium from a chlorine, from a NaCl solution. So this is about the electrolytic refining. So tomorrow I'll just discuss about the alloys. So that will be the last part of this metals and non-metals. Thank you.